short history. In 1964, George Helmier created the first working LCD using a method as carpet light. Later in 1960s, researchers in the UK found a special liquid crystal that worked better at different temperatures. 1968, Bernard Lechner suggested using thin film transistor to control LCDs and showed a basic display. 1970, Martin Scott and Wolfgang Frisch invented and twisted the twisted pneumatic LCD, which is still widely used today. So moving on with the definition of LCD. LCD stands for liquid crystal display. It is a flat screen technology that uses liquid crystal to control light and create image. Because liquid crystals do not make light by themselves, LCDs need a backlight to be seen. So how do LCDs work? Liquid crystals are special materials that can flow like a liquid but also have an ordered structure like a solid. Inside an LCD, there are two glass layers with polarizing filters placed at right angles, and without electricity, the liquid crystal twists the light so it can pass through, making the screen look brighter. And when electricity is applied, the liquid crystal straighten out and stop twisting the light. And this block the light and the screen will look darker in that area. So by turning these pixels on and off, LCDs can show different images and videos. The thickness of the liquid crystal layer is carefully designed so it rotates the light correctly when it was needed.
So the structure of the LCD. An LCD is made of several thin layers. First, the backlight unit provides the necessary illumination since liquid crystal can't light. Next, the rear polarized align the light in one direction. The light then passes through glass substrate with a transparent electrode and an aligned layer that around the liquid crystal. At the center, the liquid crystal layer twists light depending on the voltage. A second layer, alignment layer, and the electrode control each pixel. Next, for the color display, a color filter creates a red, green, and blue subpixel, and then the front polarizer decides whether the rotated light passes or gets blocked. So finally, a protective cover will shield or cover all these layers. So next, I will explain how LCD or the liquid crystal display works step by step briefly. So first, a backlight behind the LCD panel shines white light forward. And this light passes through the first polarizer which only allows light vibrating in one direction to pass. Next, the light enters the liquid crystal layer which sits between two glasses separated with a transparent electrode. When no voltage is applied, the liquid crystal naturally twists the light's polarization by 90 degrees. This rotated light can pass through the second polarizer, making the pixel appear bright. However, when the electric signal is detected by the controller, it applies voltage to a specific pixel electrode. So this voltage causes the liquid crystal to untwist and align with the electric field, so the light does not rotate anymore. As a result, the light gets blocked by the second polarizer and the pixel appears dark. By varying the voltage, we can control how much the liquid crystal twists, which changes how much the light passes through, which allowing the precise control of the grayscale and the color level. Finally, in a color LCD, red, green, and blue filter on each pixel combine different intensity to produce a full color images. This entire process happens across a million of pixels to create a clear, vibrant display that we use every day. Now, look how a signal detection works in an LCD. First, the controller sends an electrical signal which is detected by the driver IC. This causes the voltage to be applied to the pixel electrode, which changing the alignment of the liquid crystal. As the liquid crystal is rearranged, they modify the polarization of light passing through them. Finally, depending on the light rotation, each pixel brightness of the color is determined, creating the final image we see on the screen. This precise control of the electric signal of a liquid crystal is what allows the LCD to display detailed and high resolution images throughout the screen.
Okay, hello everyone. So my name is Asrullah bin Abdul Kamal. So I will talk about the principle in liquid crystal response. Okay, for the first slide is liquid crystal response to electric signal. So liquid crystal are very responsive to the electric signal. So when no voltage is applied, the molecule inside the liquid crystal layer remain twist. So this twist structure rotate the direction of incoming light. So this will allowing it to pass through the second polarizer. As a result, the pixel appear bright on the screen. So when the voltage is applied, the molecule align in a straight direction. So this alignment stops the light from rotating, causing it to be blocked by the second polarizer. The pixel then appear dark. By adjusting the voltage level, we can control how much light passes through, which determines the brightness of each pixel. Okay, next is light control using polarizer. So LCDs use two polarizing filters placed at front and the back of the screen. So the first polarizer allows only light that vibrate in one specific direction to pass through. When no voltage is applied, the liquid crystal twists the light so that it matches the alignment of the second polarizer. So this let the light pass through both polarizer, and the pixel appear bright. When voltage is applied, the liquid crystal do not twist the light because the light direction does not match the second polarizer and it is blocked. So this makes the pixel appear dark. The image on the screen is formed by controlling which the pixel appear bright or dark based on how the liquid crystal interact with the light. Okay, for the last slide is the signal detection in LCDs. So the LCD work by receiving digital signal from a controller such as a microcontroller. So this signal tell the LCD whether to interpret the input as a command or display data. So the LCD has input pins including RS, E, and data lines D0 to D7. So the RS pin select whether the input is command or data. So the E pin, which stand for enable, activate the data reading process. When the signal change from high to low, the LCD detect the data present on the D0 to D7 pins. So based on this data, the LCD updates the pixel display to show the desired content.
Hello everyone, my name is Steve, and today let's talk about the result and discussion. So let's move on to the table 1, which is the signal and operational parameters for liquid crystal display. So the operational voltage that we use is mainly direct current that is set from 3.3 volt to 5 volt, and we usually use TTL as the signal type, but we may also use LVDS and SPI. The next one is that the refresh rate, which usually set from 60 Hz along the way to 240 Hz, and the response time is usually between 20 to 25 milliseconds. And lastly, the display type that we usually use is twisted pneumatic, but we may also use IPS and VA for advanced LCDs. Next, so let's compare the LCD with the standards, which is LED. So the first thing is that LED has higher efficiency than LCD, and LCD has limited waving angle, while for LED it has a wide waving angle. But for LCD, it is cost cheaper than LED, and LCD can produce a good color, but the black color is not a true color, meanwhile LED can only produce a moderate color. So moving on, let's talk about the applications of LCDs. The first one is that it can be used to produce consumer electronics such as TVs, monitors, or smartphones, as in the mid-range model. The next one is that it being used to produce portable devices such as digital watches, calculators, or e-book readers. It is also being applied industrially to make instrument panels, diagnostic display and control systems, and last but not least, it may also be used to produce medical equipment such as heart rate monitors or ultrasound displays. So let's talk for the final part for the result and discussion, which is the pros and cons. So for the pros, LCD is energy efficient, it has low manufacturing cost, it is thin and lightweight, and it also has long operational life. But the cons for LCD is that it requires backlight, which can limit the true black contrast. It has narrower wing angle. It has slower response times if we compare it to LED. And last but not least, the color shift is at extreme angle. So I think that's all for the result and discussion. So let's move on to the next part. Thank you.
Okay, Assalamualaikum. Next is the future improvement and the trend. So basically, there's four that I classify. First is the applications for scalable industry. So the LCD or liquid crystal display will have a future economic and safety evaluation of various LCD design, which means it's not just on the design that we talk about, but also there's several various design that will be introduced in the future. for the future improvement. And the second one is due to the high optical stability of nanoparticles. So when it's incorporating with the liquid crystals, it will produce cleaner brightness and color purity. And the next one is the eco-friendly recycling technologies. And as you can see, it will form a hybrid mechanical physical chemical process with using the mild acid microacid extractions, as can make a less waste, aqueous polar solvent mixtures for delaminations, and ion actions purification for indium. So basically, this is all the good process to make the cost effective and the eco-friendly of the LCD. And then the fourth is the high quality and defect-free fabrications. So progress of large area defect-free LCD panels via automated fabrications in robot operated will improve the yield and cost efficiency with the high quality and defect-free fabrication. So in conclusion, the liquid crystal display or LCD use liquid crystal to modulate light, not emit. And as you can see from the history that was presented by my fellow friends. And then the working principle, which no voltage, real voltage, control of pixel brightness based on electric field strength, and signal detection via digital signal, and the comparisons of LCD and LED in terms of the cost, of the angle, color, efficiency, and the pros in terms of the energy efficiency, the cost effective, the backlights, and the response time, which means the cons is the slower response time. And LCD design layer is a backlight unit as a polarizer, electrodes, liquid crystal layer, and color filter and protective cover. And for the future trends, as I explained earlier, it's eco-friendly, nanoparticle, advanced fabrications, and safety assessment.